question is we need to find mass. We need to find acceleration of the inclined plane. Basically, acceleration of the M2. So first of all, as usual, we need to draw a free body diagram for both objects. So let's start with M1, for example. Mass 1, object 1. So let me draw it separately here. And we have it's M1G downward, and upward in this direction we have a force, and this angle actually equal to alpha. And the normal force, because we have a contact between M1 and the M2. I think that's all. We have 3 forces, no friction. And now let's draw a free body diagram for the inclined plane. Inclined plane we have here, and what kind of forces acting on this object, on this inclined plane. Downward we have M2G. In this direction we have a force, and in this direction also we have a tension, which is force. Upward we have a, let's call normal force 2, normal force between surface and this inclined plane. And in this direction we have a N, let's call it N1. I think that's all. We have 5 forces acting on this inclined plane. So let's apply Newton's second law for the object with mass M1, and let's apply Newton's second law in 2 directions, in y and in x, as shown in this figure. So in order to do this one, first of all we need to find all forces in horizontal direction and in vertical directions. Basically this means components of F, this one, and the component of the reaction force N1. So this will be F times cosine alpha. Upward we will have F times sine alpha. Basically now we can remove this one because we rewrote it in terms of components. And N1, it also has 2 components. So here is alpha. So to the left we will have N1 times sine alpha. Upward we will have N1 times cosine alpha. Cosine alpha. And we know that this object will move roughly in this direction. Yes? So in horizontal direction it will move to the right. It means F cosine alpha is greater, bigger, larger than N1 times sine alpha. So let me apply this one. Resultant force or total force in x direction should be equal to M1 times AX. Yes? So resultant force in x direction for this object equal to F times cosine alpha minus N1 times sine alpha equal M1 AX. Very simple. In vertical direction, like it will move upward, yes, approximately. So N1 cosine plus F sine alpha is greater than M1G. That's why it will go upward. So resultant force or total force in vertical direction should be equal to M1 times acceleration in y direction. And resultant force in vertical direction equal to N1 cosine alpha plus F sine alpha minus M1G equal to M1AY. Now let's come to the second object, inclined plane. We know that it will move only in horizontal direction and to the right. So basically we can apply Newton's second law, basically F equal to ma, only in one horizontal direction. First of all, we should determine all forces in horizontal direction. And this force has a x component or horizontal component, which is equal to F times cosine alpha. And it also has a vertical component, but it is not important at the moment. And this N1 has a horizontal component to the right, N1 times sine alpha. Basically, we have three forces, F N1 sine alpha and F cosine alpha. So let me apply Newton's second law for M2 in horizontal direction. M2 times, let's call it A0 or A2, it doesn't matter. And the resultant force in x direction, F plus N1 sine alpha minus F cosine alpha equal to M2A0. So we have three equations, but four unknowns, Ax, Ay, A0, and the reaction force N1. It means, logically, in terms of mass, we need equation number 4. And for this kind of problems, this equation number 4 is the relationship between accelerations. Now we will try to find a relationship between accelerations. For this, let's draw initial position of the system. For example, M1 was here, and after some time, their positions will be like this, approximately. And this is the direction of the motion object M1. Here we have an angle alpha. So let me consider this triangle. Why? Because this angle is given, alpha. And this is a distance that object M1 moves upward. So let's call it y. And this distance, this is a difference between distance that M1 moves in horizontal direction and the distance that M2 moves in horizontal direction. Why? Because of this figure, this distance is a distance that M1 moves in horizontal direction. This distance is a distance that object M2 or inclined plane moves. Let's call it x0. So this part, this length equal to x1 minus x0. So now we need to pay attention to this triangle, right triangle. So this height y equal to y, this base equal to x1 means minus x0. x1 is a distance that object M1 moves in horizontal direction. x0 is a distance that inclined plane, object M2 moves in horizontal direction. According to this right triangle, we can write this equation. Tangent alpha equal to y divided by x1 minus x0. Y is proportional to the ay acceleration. x1 is the acceleration proportional. X1 is proportional to ax. x0 is proportional to the a0. So this is the equation number 4. Or we can say ay equal to ax minus a0 times tangent alpha. So now further we can solve it. It's just a matter of mass and time. From equation number 1, a0, acceleration of the inclined plane, will be equal to f plus n1 sine alpha minus f cosine alpha divided by m2. So in this equation we have only one unknown basically, or n1. So from equation number 2, ax equal to f cosine alpha minus n sine alpha divided by m1. From equation number 3, ay equal to n1 cosine alpha plus f sine alpha minus m1g divided by m1. So what we will do next, basically I will take a0 into the equation number 4, ax, I will take it, I will substitute into equation number 4. Same for ay, I will substitute in equation number 4. And in this equation we will have only one unknown, which is n1, and our aim is to find n1 at the moment. So first is just math, I will do it quickly.